Okay, so we are going to start talking about refraction of light. So remember, when we talked about properties of waves, we were able to discuss some of the little things we need to know about refraction. So but now we are going to talk more about refraction of light. Okay, so remember, in our definition we said that refraction is the change in direction of a wave due to change in speed as it crosses the boundary between two media. So imagine I have glass. This is glass, and I have a ray of light coming in this way. Okay, now that ray of light does not continue on this part. Instead, it is refracted. It is refracted. Okay, so the angle here is known as the angle of incidence, and the angle here is known as the angle of refraction, not reflection. So remember, under reflection we talked about angle of incidence and angle of reflection, but here we are going to talk about angle of incidence and angle of what? Refraction. Okay, now one of the laws of refraction, which we also call Snell's law, so pay attention, Snell's law, which is the second law of refraction, and that law says that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant for a given medium. Let me go again. I said that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant for a given what? Medium. And what do we mean by that? We are saying that n is equal to sine I over sine r. That is what Snell's law is trying to tell us. In this formula, n represents a constant we call refractive index. Refractive index. I represents what we call angle of incidence, and then of course r is your angle of refraction, So that is that about Snell's law. So we are going to be using this Snell's law very extensively to solve questions. Okay, now another thing we also need to talk about under this law of refraction is the first law of refraction. I did not talk about that. So first law of refraction is similar to the first law of reflection. You just replace the reflected ray with refracted ray. Okay, so the first law of reflection is saying that the incident ray, the normal ray, and the refracted ray all lies on the same plane. Just like in the case of reflection. Okay, that is what that law is trying to talk about. Now, it is very important that we understand what n represents. So n represents refractive index. Okay, n represents refractive index, and this refractive index can easily change. Depending on the direction of the motion of light. Light. It can always change. Okay, so but we are going to talk about that more in details in the future. Okay, so now the next thing we are going to talk about under refraction is where can we observe refraction in nature? Where are the places? What are the things we can see and say, this is refraction? So examples of refraction. So imagine you have a bowl. That contains water inside of it. And then I place a rod, a metal rod, or maybe a stick inside of that water. Now, because of the phenomenon of refraction, you see that this rod will appear bent when I observe it from the surface. It will appear as if it is bent. So somebody that is looking at it from the surface, it will appear as if this rod is bent. If you have never observed that before, try that at home as an experiment. So if you can put a spoon inside a cup and observe the spoon from the surface of the water. You see that as you are looking at the spoon, it will look as if it is bent. This is due to what? Refraction. It is due to refraction. Okay, another example of how we can see refraction is in the field of view of aquatic animals. So let me use a fish as an example in their field of view. So imagine I have a pond, and then in my pond I have a fish. Okay, so I have a fish in the pond, and then this is the surface of the water. Now, whenever a fish is looking at the surface, you see that because of refraction, the field of view of the fish is increased. Let me show you what that means. So look at the rays of light coming out from the fish eye. Look at the rays of light. So when the ray of light gets to the surface, it gets refracted, and because it is going into a less dense medium, it refracts away from the normal. So you see, it is going to refract this way, and once that refraction occurs, it is also going to happen here, refract this way. So you see that the field of view, this is the field of view of the fish is increased. When it was in water, it could only see this portion, but because the rays refracted, the field of view increased. Okay, so that is another instance of refraction in nature. But we are going to talk about one of the important applications of refraction, or where we observe refraction in nature, and that is in the concept of real and apparent depths.